Okay, today we're going to talk about lesson 62 and lesson 69. This is going to be over complex numbers. So for today, we're going to need to use our imagination. Because what we're going to be talking about is our complex numbers system, which will include imaginary numbers, which is pretty exciting. So let's look back. Okay, and this is just kind of a precursor. I don't know that I have a slide here for you guys for this, but we've already went over our real number system. In our real number system, all real numbers are either irrational or they are rational. Okay, irrational numbers being our numbers like pi, e. We haven't talked about e yet, but we're going to talk about that here pretty quick, actually. And then our rational numbers are our fractions, our terminating decimals, and our repeating decimals. Now, underneath our rational numbers, we had integers. And underneath our integers, we had our whole numbers. And then underneath whole numbers, we had our natural numbers. So this was our number system as we know it. But today we're going to add to that. Today we're going to talk about our complex number system. And all complex numbers are either going to be real or they are going to be imaginary. So we're going to start off in this imaginary realm, and then after we get done talking about just our imaginary numbers, we're going to come up and we're going to talk about our complex numbers. So we have just expanded our number system that we are looking at. So, starting out then. Okay, solve x equals plus or minus square root of negative 4. We've never been able to solve that before because there are no real solutions. Now, I've told you guys that before, that there are no real solutions, but I don't think we really understood what that meant. There are no real solutions. There are solutions, they're just not real numbers. So this equation does have a solution within the set of imaginary numbers. Okay? An imaginary number is written in the form of bi. Okay, b is just some real number, and then I is what tells us that it's an imaginary number. So essentially what you guys need to know is the square root of negative 1 equals I. And that's the most important part of what we're going over today. The square root of negative 1 equals I. Okay? So the square root of any negative number is going to give you an imaginary solution. So if I look back up here and I have a square root of negative 4, okay, what we're going to do is we are going to use our product property for roots, which says that I could split up what's underneath my square root. So I could split up a negative 4 and make that a 4 times a negative 1. Then I can split up my roots, make that a square root of 4 and a square root of negative 1. Do we know what the square root of 4 is? Yes, hopefully the square root of 4 is 2. Okay, and then what's the square root of negative 1? We haven't talked about. Oh wait, we have the square root of negative 1 equals I. So basically, all that we do for this, if I have a square root of negative 4, that equals 2I. Okay? So you just look at the number, the square root of the number, and then you tack an I on at the end of it. Okay? Oh, well, we'll skip that one because that's where I was drawing my picture. Okay, so simplifying, the square root of negative 49. Square root of negative 49. I want to split this up. And I can split this up into a square root of 49 and a square root of negative 1. What's the square root of 49? Well, that's going to give me 7. Okay, what's the square root of negative 1? We just talked about that. That's going to give me an I. So my answer, square root of negative 49, is 7I. Okay, process that. Let that sink in a little bit. I'm going to do some more practice ones. You guys can write these on the margins of your paper here. Square root of 36. Sorry, square root of negative 36. Well, what's the square root of 36? It's 6. And then there's a negative, so I tack on an I. Square root of negative 100. What's the square root of 100? 10. Okay. Then there's a negative. That makes it I. Square root of negative 25. Okay. Pause the video if you want to give yourself a chance to see if you're right on this. Square root of negative 25. That's going to give me, what's the square root of 25? It's 5. There's a negative underneath it, so I tack on an I. Square root of negative 1. Well, that's our basis of the whole thing. That's I. Okay? So it's just taking a normal square root, and since there's a negative, we put an I on the back of it. And that's all that you have to do. Okay? Next one that we're going to do on our next slide is a little bit more complicated than that. Okay, so it's a square root of negative 153. So I go through the same steps. I'm going to split this up. Square root of 153, okay, and a square root of negative 1. Okay, I split it up just like normal, what I had been doing. But the difference is on this one, do we know what the square root of 153 is? No. Can I find what the square root of 153 is? Yeah. 153 is not going to be divisible by 2, but it is divisible by 3. So I can break this up into 3 and 51. 51 is also divisible by 3. Gives me 3 and 17. So I'm looking for pairs. There's a 3 on the outside. There's a 17 on the inside. And then the last piece that I can't forget about this, my square root of negative 1. Well, square root of negative 1 is just an I. So I tack an I on at the end of it. Okay, so it's a 3 square root of 17 I. Okay, so basically any time that there is a negative underneath the square root, you just need to put an I on the end of it. And that I tells us that it's an imaginary number. Notice on this that the I over here, the I is not underneath the square root. Okay, it's just on the back of it. Okay, other things that we can do with imaginary numbers. Okay, we can perform operations. Oh, wait, never mind. I'm ahead of myself. Sorry. So we're going to talk about complex numbers now. So complex numbers, our imaginary number is BI. Okay, and that is part of a complex number. Part of a complex number. A complex number is anything that is written in the form of A plus BI. So A is a real number, and then my BI is the imaginary part. Okay? So A is the real part of a complex number, and BI is my imaginary part. So a complex number is made up of a real part and an imaginary part. Okay? So for example, a complex number could be 2 plus 3i. That's a complex number. A real number that we're used to doing, a real number could be 2. Okay, so if I wanted to write 2, if I'm writing 2 as a complex number, I would be 2 plus 0i. Okay, because there is no imaginary part to that. Okay, 0 times I would just give me 2. So that's how 2 equals the same thing as this part right here. So if I were to write this as a complex number, I have to have for a complex number a real and an imaginary part. So I've got 2 for my real number and then 0 for my imaginary part. It's not really there. Same thing if I have an imaginary number. Okay, say I had 3i. Well, if I wanted to write that as a complex number, I'd do 0 for my real part because there's no real part. 0 plus 3i. Okay, so that's really just our imaginary part, 3i. So your complex number, and this is important, all complex numbers have to be written in this form. They all have to be in this form. Okay, the real part, then the imaginary part. All right, now we're going to talk about operations with complex numbers. Okay, so starting out, to add or subtract complex numbers, you're going to add or subtract the real part and add or subtract the imaginary part. So basically, you're going to pretend like your I is just a variable, and you're going to combine like terms. Okay? So if I have 11 plus 2i plus 6, plus a negative 6 minus 7i. Okay? That's a complex number. That's a complex number. I've got a plus sign there. So with my plus sign, I really don't need to worry about those parentheses. Okay? I've just got an 11 plus 2i minus 6 minus 7i. Okay? And all I'm going to do is combine like terms. I'm going to combine my imaginary part, and I'm going to combine my real parts. Okay? So 11 and negative 6, that's going to give me a 5. Positive 2i and a negative 7i, that's going to give me a negative 5i. Okay? And that's all I do. It's just combining like terms. Okay? Subtraction is the exact same thing. It's just combining like terms, except I have a negative here. So I'm going to have to distribute that negative to both. So that's going to give me an 8 minus 4i minus 8 plus 16i. Okay? So 8 and negative 8 gives me 0. And then a negative 4i and a positive 16i gives me 12i. Okay? So this here, those two would just cancel each other. Okay? And then a negative 4i and a positive 16i gives me 12i. Okay? And that's my answer for that there, just a 12i. If, and we just talked about this on the last slide, if they said that you had to have this in a standard form, okay, remember our standard form is a plus bi. Well, my 12i is my bi, so what would my a be in this case? My a would just be a 0. So it would be 0 plus 12i. Okay? But I would be perfectly okay with you guys just writing that down there. Okay? So, adding, subtracting, not a big deal. You're just combining common denominators. Okay? Next thing that we're going to talk about is we're going to talk about powers of I, and this is where we get into our multiplying. Okay? And I'm going to go ahead and talk about that on the next video.